You're asked to consider k of x, which is an exponential function. The first thing we're asked to do is to describe the transformations from the parent function. And when we're dealing with this one here, I can see there are two transformations because we have 2 to the power of x, then we have this 3 that's being multiplied in the front, which is what we call an a value, which in this case is a vertical stretch because it's a number that's greater than 1 by a factor of 3. Then we have this number being added within the exponent, which we're going to call our h value. And this one's a little bit weird because, it's kind of the reverse of what we would think. If it's x plus 2, we're shifting this horizontally. So we're going to call this a horizontal shift 2 units to the left. So again, it's reverse of what you might think with an h value because usually think if we're adding, we're going to the right, but in this one, it's kind of the reverse. So the second question here asks us what is the y-intercept of this equation, and to do that, all I really have to do is just plug in the x value of 0 and kind of evaluate to figure out what the y value is. So 0 plus 2 is just 2, and now I have to remember, order of operations, I have to do exponents first. So I have to do 2 squared before I multiply by 3. And then I get my y-intercept at 0, 12. Write the equation of an exponential function in the form m of x equals a times 2 to the power of x. So instead of having an a value and an h value, it's asking us to have an equation that has the same y-intercept, so 0, 12, but with an a value only. So pretty straightforward to do that. We're just going to take this equation here and then plug in this intercept because we know that that's one of the points that lands on that line. So we have 12 equals, we don't know a yet, times 2 to the power of 0. And this one's nice and easy because anything to the power of 0 is just 1. So my a value is equal to 12. So my equation for m of x is just 12 times 2 to the power of x. Sorry, a little messy there. Now the last one says, are our original equation and this new m of x equal? And I'm going to tell you the answer to this is yes. And the reason for that is we'll start with k of x here. I'm going to use some exponent rules to help me show algebraically that this is true. And the rule I'm going to use is kind of the reverse of the product rule, because what I know is that 2 to the power of x times 2 to the power of 2. Remember, with the product rule, we can say that two exponents with the same base, we can add those exponents together. So I'm doing that backwards. So really, this is 3 times 2 to the power of x times 2 squared. Now, with order of operations, I have to do the exponent stuff first. I can't actually evaluate this one, 2 to the power of x, but I can do this one here. So 3 times 2 to the power of x times 4. And because with multiplication I can rearrange, I can do it in any order that I want. I'm going to multiply 3 times 4, which leaves us with multiplying it by 2 to the power of x. And so we see that k of x is the same as m of x.